typically when you do a life cycle assessment, you look at different damage categories. So there are so many aspects of environmental sustainability, perhaps the most important one being at this point of time, carbon emissions. But if you are producing your product in an area where you have a water shortage, that may be a focus area to save water because our industry is super water intensive. Whereas if you have plenty of water available, you may focus less on that. And then you have other things like resource depletion, for example, how much resources are you consuming in this? It's very obvious with all the plastics that we generate in our processes that consumables is focus area.
Welcome back. In part 1, Niklas Jungnelius opened our eyes to the hidden economics of bioprocessing. Now, in part 2, we're shifting gears to tackle the elephant in the room, sustainability. How do you actually quantify environmental impact? What's stopping biotech from hitting those ambitious carbon neutral targets? And with AI and continuous manufacturing changing the game, how do you model technologies that barely have historical data? Niklas is bringing his process modeling expertise to answer these burning questions. Ready to future-proof your bioprocessing strategy? Let's go. Are you juggling the complexities of CMC development while trying to enjoy the beauty of biotech? Have you ever wondered if there's a way to simplify bioprocessing? Welcome to the Smart Biotech Scientist podcast, where we're diving headfirst into the very challenges you face. We're breaking it down, demystifying the jargon, and giving you the keys to unlock your full potential. I'm your host, David Brühlmann, and I get it. With 15 plus years in the biotech industry, I face the same challenges you do. There's a way to simplify and streamline so you can remove complexity, you can skip trials and errors, deliver without delay your groundbreaking therapy to clinics and market, and still enjoy every single step. Do you want to learn how industry experts and I did it? Grab a cup of coffee and your favorite notebook and pen. Now is the time to take your bioprocessing game to the next level. Let's smarten up biotech. I would also like to focus on another part. Obviously, process economics is important. The other one is the environment, and many big companies have set ambitious sustainability targets, being carbon neutral by 2030 or 2040, depending on the context. What are the biggest technical and economic hurdles preventing biotech companies from reaching these goals?
That's an interesting question. I think if we focus on the relative targets that many companies have set up, such as an 80% or 90% reduction in CO2 emissions, for example, compared to a given baseline year, it very much depends on what your baseline is, of course. And that is not as easy as it sounds to find out, because it's still a lot of data missing in trying to assess your true carbon emissions. We need to make assumptions, and we get more and more data on this over time. So it may be that things are changing slightly as well. So somewhat of a moving target, perhaps. But the baseline will determine a lot what your viable options to reduce are. If you have a baseline situation where you have been using a lot of fossil energy in your operations, that will typically have a very high impact on your carbon footprint. In that case, the most obvious thing to focus on to reduce would be to switch to some renewable energy source. That can make a huge difference in the CO2 footprint and substantially reduce your emissions. On the other hand, if your manufacturing facility was using renewable energy from the baseline year, say in Switzerland, for example, I know, David, that you have a lot of renewable power in the electricity grid. Then you have a much cleaner profile in the baseline year, but you also have a much tougher time getting to those 80 to 90% reductions. So that means you need to work much more with other factors, and that is typically including consumable emissions. So your scope 3 emissions, the emissions that you're not sort of responsible for yourself, but your vendors. As a supplier to biopharma, Cytiva has to work extensively not just to introduce new products that are more sustainable or have lower carbon footprint, but also to reduce the emissions of the existing products we have. I mean, our clients are not able to replace all the products in their processes just to make them more environmental friendly. If we can work on our end to reduce emissions of existing products, for example, with using renewable energy, working with our suppliers, finding alternative starting materials, we can significantly help our customers reach their sustainability ambitions.
If we look at the consumables we're using or raw materials, what comes into my mind just like this is obviously single use, a lot of plastic, that's where the CO2 lies, but also biopharma uses a lot of water. First of all, are these the main drivers or not? I'm curious about that, and what are actually the real drivers?
I think it depends on what damage category you're looking at, because typically when you do a life cycle assessment, you look at different damage categories. So there are so many aspects of environmental sustainability, perhaps the most important one being, at this point of time, carbon emissions. But if you are producing your product in an area where you have a water shortage, that may be a focus area to save water, because our industry is super water intensive. Whereas if you have plenty of water available, you may focus less on that. And then you have other things like resource depletion, for example, how much resources are you consuming in this? But if we stay with the carbon footprint, I think it's a good point. It's on most people's minds, or people have an opinion about this. It's very obvious with all the plastics that we generate in our processes that consumables is focus area. Perhaps I would argue that I don't think, with the data we have at hand today, that our main focus should be on the recycling side. Even though it's very tempting, it's very visual to see all of those piles of plastics. I think the benefit we get from recycling those in relation to the emissions that we have in the production side, that will be much smaller. And also, given we are a relatively small business, we are few biopharma companies globally, we will have a challenge with transports, etc., in the recycling chain of these products. But in the production step, we have large wastes, we have a production that is carried out in clean rooms, which is energy consuming, etc. So I think that is where we will find our hotspots. And with environmental sustainability, I should add also that it's always a surprise when you do a life cycle assessment on a product and really find out what are the true drivers, because sometimes it's one obscure chemical that you never thought would have that big of an impact. And if we can eliminate that or replace it with something else, that may make a huge difference to the sustainability of your product.
Before we continue, biotech founders, I want to talk directly to you. Do you know that feeling when an investor asks about your manufacturing strategy and you freeze? One wrong CMC decision can cost you $2 million and 18 plus months of delays. Yet many CEOs are flying blind on these critical decisions. That's why I created the 1-week CMC strategy assessment. In 1 week, you get a personalized assessment of your molecule and development stage. We identify critical gaps before they become million-dollar mistakes, plus a strategic roadmap for high-stakes investor meetings. One CEO told me, "David took me from feeling powerless about our CMC roadmap to confidently pitching investors. An absolute game changer for time-pressed CEOs." Whether you are preparing for Series A, approaching IND filing, or facing scale-up challenges, this gives you confidence to ace investor and board conversations instead of surviving them. Ready to stop second-guessing your CMC strategy? Check the link in the show notes and secure your spot. Because your breakthrough therapy deserves a solid CMC strategy. Now, let's get back to our episode. Let's get tactical here, because some of our listeners, whether they're in process development or manufacturing, they think, Okay, that's great. I want to monitor that, but where do I start? So can you give some advice how you should start? And also, how do you actually measure these important parameters?
I think that it has a lot of potential to work more with process modeling, and we see that from the big biopharma that they implement process modeling at an early stage of development now to develop smarter, more efficient processes. And I think one key thing is that you should think manufacturing from start in process development. Sometimes your time horizon may be more limited. If you're a startup, for example, you may not have the resources or even the knowledge to have the detailed view of your future manufacturing process. But I think that should be the starting point, including, of course, the steps along the way, the sort of commercial production, etc. But with the end in mind, we will make better decisions. Then I think you will need to think about the scope of the modeling and the ambition level. So what are the benefits you will get from this? How much effort is it worth to invest in different stages? Would we start looking at separate unit operations, or would we look at full processes? That may be dependent if we have a platform or not. The level of detail in the models will decide whether you go broad in your initiative to have many people trained on this, have it in all PD or MSAT labs, for example, or if you want to have one or a few experts in the company working with this. Because if you have a lot of details, if you want this to be very accurate, you need to work with this more or less daily, I would say, because it's a very tough add-on to someone to stay updated with all the parameters, all the inputs, and work with that in an accurate way on top of another position. The more accuracy, consider having individual experts working with process modeling.
Before we wrap up, Niklas, what burning question haven't I asked that you are eager to share with our biotech community?
I would say that there is no single manufacturing technology that is superior in every situation. All the time, it depends on your inputs and your assumptions. If you compare, for example, fed batch with continuous manufacturing, it makes a huge difference if you start your comparison with a certain titer or if you double that titer. That will make or break the business case either way, I would say. Asking in general what is the best manufacturing technology, I would say, is a bit like asking a question like what's the best way to go to work? And the answer is always it depends. I mean, it depends on the traffic situation you have, how far from work do you live, what transports are available, how much money are you prepared to spend on commuting, for example, among other things. Being aware of the implications of the different options will help you make the best decisions for your specific needs. Process economic modeling can help guide you to that manufacturing strategy that best meets your individual needs.
And if we look ahead, Niklas, is there any trend in the bioprocessing industry that will completely change our models or assumptions?
I think what's somewhat shifting now is how do you work with technologies like intensified fed batch, where we increase the productivity in batch production bioreactors by front-loading the cell expansion. Like I said, titer is an important parameter here that sort of shift the case a bit towards batch manufacturing. We have hybrid versions where we have perfusion bioreactors and batch downstream, for example. But I think if we want to look a bit further ahead, we may see new manufacturing technologies where we have things like cell-free expression, for example. If we're looking for real change, for transformational change, that is where we need to look. But that's much more uncertain as well. And there are many different options to go for, each with a need become much more optimized for manufacturing situations.
We've covered a lot of ground today. From all that we've discussed today, what is the most important takeaway you want us to walk away with?
I think from my side, understanding that depending on what you focus on, depending on your specific prerequisites, your needs and ambitions, different solutions will be differently suited for your manufacturing process. I would perhaps want to turn that question to you, David. Have you learned anything today that you think can be useful in your work as a strategic advisor to the biopharma industry?
Absolutely. That's a great question. I like it. One thing I've learned is how to say it. There is no one size fits all solution. It really depends on your scale, on your phase you're in, whether you're more in the clinical phase versus to getting closer to a manufacturing scenario. I think it depends a lot the kind of choices you're making, whether you're going to opt for more single use versus stainless steel or larger scale. And the other thing I think is important, it's also depends on your modality. Finally, what it will be the volume required and the productivity, as you said. This is key to consider that from the very beginning. Ideally, have a much greater productivity in your process, because I think that's where you can gain a lot of time and also money.
Thanks a lot. I think that's a very good answer. I'm very happy with that.
Excellent. That's great. I passed the test. Yoo-hoo!
Yes.
So this has been fantastic. Niklas, thank you for your insights, also for your thought-provoking question at the end. I love it. Where can people get a hold of you?
I would say easiest thing is to connect on LinkedIn. Perhaps you can put my address in the pod.
Sure. I will do that. Smart Biotech Scientists, just check out the show notes of this episode. You will have the information there. Please use the opportunity to reach out to Niklas, ask your process economics modeling question. And once again, Niklas, thank you so much for being on the show today.
Thank you so much, David. It's been a pleasure and happy to connect with anyone who wants to discuss more about this very interesting topic.
This wraps up our conversation with Niklas Jungnelius from Cytiva. From quantifying environmental footprints to navigating emerging technologies, Niklas has given us a masterclass in thinking beyond just cost of goods. Remember, every process decision you make today shapes both your economics and the environmental impact tomorrow. If this episode sparked new ideas, do us a favor and leave a review on Apple Podcasts or your favorite podcast platform. Your feedback helps us serve you better, and thank you for tuning in. Until next time, keep doing biotech the smart way. All right, smart scientists. That's all for today on the Smart Biotech Scientist podcast. Thank you for tuning in and joining us on your journey to bioprocess mastery. If you enjoyed this episode, please leave a review on Apple Podcasts or your favorite podcast platform. By doing so, we can empower more scientists like you. For additional bioprocessing tips, visit us at smartbiotechscientist.com. Stay tuned for more inspiring biotech insights in our next episode. Until then, let's continue to smarten up biotech.